So today I had my students use this code here that you've seen before about setting up a bunch of atoms that you can apply a torque to rotate. And just like on the video from earlier, I gave them a few problems saying, change the shape that you have there, make it a cylinder, make it a sphere, and then make it rotate. And, tell me if the rotation makes sense. And they encountered what I imagine maybe a few of you have encountered. Let's see what happens if you actually try to make this ring into a cylinder. It is not something that I expected to see. So to make this into a cylinder, we're going to indent it. Then we're going to loop over z while z less than or equal to, let's go up to 1, all the way to 1. How about that? And so you do the thing that you did on the moment of inertia video, z equals z plus dz. Remember I said I left that for you as an exercise to do. Well, you should always be wary when a professor says that, because then you get error messages like this at the bottom of the screen. Compounding objects 0 through 66 in the list exceeds the vertex limit. And everybody in class at the same moment was getting this error message on their screen, and I had no idea what error number 66 meant.
Execute order 66.
And I said, that's weird. What's so special about the number 66 there? And so I thought it might have something to do with the compound function down here in line 37, because it says compounding objects 0 through 66 exceeds the vertex limit. I didn't know what vertex limit meant. And so I said, okay, well, it probably has something to do with this. So I tried finagling the number of spheres. Sure enough, once you pass 66 spheres, once you pass number 65 going to 66, it says I can't do that anymore. I can't take any more spheres. And we all kind of puzzled and said, I wonder why I can't handle more than 66 spheres. It turns out, if you read the fine print in the documentation page about this compound, the graphics display cannot handle more than, I think, 2 to the 16 vertices at a time for one object. And you say, but this is 66, not 2 to the 16. Well, 2 to the 16 vertices means 66 spheres, because each sphere has a ridiculous number of vertices. Because it's a round shape, you need lots of vertices to display it. And so I said, I wonder what would happen if you change the shape. And sure enough, if you change the shape, it changes that maximum number, because each shape has a different number of vertices that it needs. And the one that needs the fewest vertices, or at least that I can think of, is the box. So if you trade out your spheres for boxes, you can end up with a cylinder. So you can exceed that limit. And the reason this error wasn't showing up in the moment of inertia video is because I don't use the compound function there. I just have a list of the atoms. I wasn't using the compound function until the torque video, where I didn't do this part. I just said, okay, now you go home and do this. And I did not test it. That's my bad. That's on me. I will test things more rigorously from now on to find things like that. But basically, if you trade out these spheres for boxes, you can have up to, I think it's like 3,000 something items in your compound. And so that works out a lot better. So I am presenting this to you as an updated version of this code. This code will be in the link in the description below. I'm just going to update this at the URL that it was originally at, so that people who watch the torque video in the future will just come down there and there'll be boxes, and I'll put a little note in that description. But I wanted to let you, the loyal viewer, know about that mistake and how I addressed it, and how you can avoid that error as well if you end up with that compounding error as well. My students actually did really well on the activity, though, despite that error. More than a few groups took the opportunity to create a double helix out of this. So they created a DNA strand and got the moment of inertia of DNA, which I was surprised by the result of, but I guess I shouldn't have been surprised by the result of. I'll let you try to get DNA out of this and see what its moment of inertia is. Anyway, I hope you enjoyed this code. I hope it's fun to work with. Thank you so much for watching. I will see you next time. Bye-bye.